Welcome y'all to another video. It's just math, y'all. We're going to look at graphing linear inequalities. So I've got a couple of examples, going to go really quickly. So this first one, wrong one. There we go. Here we go. This first one, we want to graph this linear inequality. And so basically our steps are as follows. We're going to graph the line that this represents. Okay, so first thing we're going to do is we're going to graph the line that this represents. And then we're going to shade the section of the plane that corresponds to the inequality. Okay, so the line is equals, and then when we shade above the line, that's greater than, and we shade below the line, then that's less than. Okay, so that's basically what we're going to do, and then we're going to check it. We're going to check it by doing a test point. Okay, so here we go. So the first thing I'm going to do is I'm going to graph the corresponding line. So I have 3x minus y is less than 3. So I want to graph this line. So I'm going to put it in y-intercept form. There are other ways to graph, but this is going to be very helpful later on. So I'm going to go ahead and do it. I'm going to subtract 3x on both sides. And I'm going to get negative y is less than negative 3x plus 3. And then I'm going to divide everything by negative 1. And I'm going to have y. When I divide by negative 1, I have to flip. We forgot that, didn't we? Yes, you did. So now I'm going to have to flip my inequality so that it's that way. And then I have 3x minus 3. Now that is just a rule that always goes with inequalities. It's the only thing different about working with inequalities is that if you multiply or divide by a negative, you must flip that inequality sign. And so when I divided by a negative 1, I had to flip it. All right. So now I'm going to graph. Again, graph the line that is corresponding here is y equals 3x minus 3. And so this is my start point at 0, negative 3. And then this is my slope, which is 3 over 1. My rise and run, I'm going to see that is up and right. So from negative 0 down, I'm going to go up 3 and right 1 and put a dot. And I can do that multiple times. I can actually go the other direction. Okay, so now there's my line. Now I haven't drawn it in yet because there is something that we need to talk about. All right, the original problem has a less than only. And the line represents the equals. I already said that the line represents the equals. I don't have an equals. So I'm going to make this a dotted line because in reality, my answer is not really part of the line. It's microscopically close to it, but not actually, because equals is not part of my question here. We'll do one in a minute where we actually do. So that's going to be a dotted line. Okay, now let's move into step 2. Step 1, we just graphed the line. Step 2, we're going to shade above for greater than, below for less than. All right, so now this one is a greater than. This is a greater than symbol. Now it's a greater than, right? It wasn't earlier, but that's what we're going by. Greater than. Okay, and greater than is above. So if I start on my line and I just draw straight up, that's this area I'm shading. So this is the area I'm shading right here. Oops, I kind of went over. So that's the area. So now, step 3 is to check my answer. Okay, so check it by testing a point. Find a point that you colored. It doesn't matter what point it is, but find a point that you shaded. Okay, so I shaded this point right here. That's the point -1, 1. Right, and I'm going to plug it in. I can plug in any point that I shaded and see if it works. So if this was my X and this is my Y. So I'm going to plug that into my problem, my original problem, and see if I get a true, which means I did it right, or a false, which means I didn't do something right. So let's see. So 3 negative times -1 minus 1, is that really, in fact, less than 3? And that's not a -3, it just looks like. So I'm going to check that, and I'm going to see that's -3 minus 1, which is -4. Move that out of the way. -4. Is that really less than 3? And yes, of course it is. So I did it correctly. All right. That's how we do that one. Let's do another one real quick. This one is a system of linear inequalities. System of linear inequalities. So I'm going to graph the line. Ooh, hope I have enough room to graph my line. I may have to go by twosies. Let me change this number because I don't have an 8 on here. Let me change that. No, that would be fine. Let's put it back. We can do it 8. Do it in your head. You can do it 8. Okay, so we're going to graph the line. All right, remember, if it has equals, it's going to be a solid. If it doesn't, it's going to be a dotted. Okay, or some people just need to know less than or equals solid, less than, greater than is dotted. Okay, so now the first one, it's in the format y is less than or equal to 3x minus 2, so it's easy to graph. 0, -2 is my start point. My slope is 3/1, so that's up 3/1. So there's my first line. It has an equals on it, so this one is going to be a solid line. All right, it says less than. This is a less than, so that means I'm going to shade below. Now, I'm not really going to shade below because I still got a lot of work to do on this problem. I'm just going to put my little arrow there. Then I'm going to shade below. So I'm just going to put my little arrow there, shading below. Okay? All right, so now I'm going to do my second line. My second line is x is less than 2y plus 8. Now, it's not in the right format. So I've got to kind of turn it around a little bit. I got to make it say y equals. So this may be a little tough. I'm going to subtract 8 on both sides. That's x minus 8. I'll divide everything by +2, so no flipping. Okay, so I have this. Well, that's really, let's get it so that the alligator's going to eat the y. There we go. So now we have y is greater than 1/2 x minus 4. So 0, -4 is my start. My slope is 1/2. So there's 0, -4. My slope is 1/2, so that's rise 1, run 2. Here we go. All right, now this one is dotted. This is a dotted line, so I'm going to dot that line. This is a dotted line. Okay, now it says greater than. Now it says greater than. Now, again, at the original problem, it didn't. It's when it's in the y equal format. If it's in the y equal format, it says greater than, then that means I'm going to shade up. So above this line. Now, a system means we have to have the shared section. We did the shared part, remember? We did the systems. We did the shared part where the points, the two lines cross, or the point that they shared. Well, in a system, we're looking for the shared section. And if you'll notice, there's only one section that is both arrows. We have 4 sections. Our 2 lines divide everything into 4 sections, but there's only one section that has both arrows, and that's that section. So that's the section you're going to shade. Okay? The other 3 sections don't have both sets of arrows pointing into it. So that's the section we can check this just the same way we checked the others, but we're going to have to plug in a number into both equations. So I could test any point that I have shaded and plug it in and see, and it should work both. I should get a true on both. So I could test any point. There's a point there, that's 3, 2. I can test that point, and I should get a true for each one. So for my check part, if I do 2 is less than 3 times 3 minus 2, well, yeah, 2 is less than 7, so it checked that point. Do the other one, is 3 less than 2 times 3 plus 8? Well, yes, 3 is less than 6 plus 8, which is 14, so it checks. So I have the correct section shaded. All right. I know this was really, really fast and really, really short. Just 2 little examples. Hope it helps. Just remember, it's just math, y'all.